Hi, today we will walk through some example of how to solve a quadratic inequality. Suppose I want to find all the solution to 2x squared. Let me go down a little bit. 2x squared minus 5x plus 2 is greater or equal to 0. Right, so how will we do this? Well, the first thing that I would try to do, as I would if this is an equal sign, is factor these things. So let's factor. So first, let's try 2x here and an x here, because 2x times x give me 2x squared, right? Now I need to find two numbers that when I multiply give me 2, and then when I combine with 2x and x give me negative 5x, right? So let's try 1 here. Let me do in blue. Let's try 1 here and 2 here. Okay. So I see the inner product is x and the outer product is 4x. But I need negative 5x, right? So this must be a negative and this must be a negative. So therefore, we have a negative here and a negative here. Okay. You can always check it by forward this back to see if it's equal to the original expression. Okay, so let me erase all that scrap work. All right. Okay, now I got this factor from here. What we need to figure out next is when this thing is positive, or in fact greater or equal to 0. Right. So one way of thinking about this is I got two number, right? I got two number, and this product is greater or equal to 0. So what are the possible signs for these numbers? So there are two possibilities. One is that either this one is positive and this one is positive, so their product will give me a positive result. Or the other possibility is that this one is negative and the second number also negative. So together their product also give me a positive result. Okay. So how would we do about this? Well, an easy way is to put together the signs and we make a side charge. So how do we make a side charge? First, we need to figure out what are the critical number. And the critical number is just a fancy way of saying finding these solution where the expression is equal to 0 or undefined. Right? So first step is finding critical number. That means I'm going to set 2x minus 1 equal to 0, and x minus 2 is equal to 0. So 2x minus 1 equals 0. Add 1 both sides. I have 2x equal 1. Therefore, x equal 1/2. So this thing equals 0 when x is equal to 1/2. Okay. The second one is easy. Add 2 both sides. We have x equal 2. Now we can make a side charge. Now we can make a side charge. Okay, so I have 1/2 here, and I have 2 here. Okay. So our goal here is to find. So I divide the side charge into 3 regions. Our goal here is to find which region will give me a positive result, right? Because remember the original equation, we want where is this thing is positive or bigger or greater equal to 0. Right? So as you can see, I divide this side chart into 3 words, right? At x equal 1/2, we know that is this thing is equal to 0, right? And the same thing as x equal 2, the quadratic also equals to 0, right? But we don't know what's going on in the between regions, right? So what we're going to do is we're going to pick a random number and then plug it back into the original equation, or even this equation, to figure it out, to see if it gives us a positive size or negative size, right? So the next thing, we're going to pick a random number. So from negative infinity, so here's negative infinity, here's positive infinity. From negative infinity to 1/2, I'll pick 0, right? Pick 0. Okay. So when I put 0 in here, I see 0 minus 0 plus 2. So plus 2 is greater or equal to 0. So therefore, this region gives me a positive result. Okay, so everywhere, whatever value you pick between negative infinity to 1/2, it'll give you a positive result. Next, between 1/2 and 2, I'm going to pick maybe 1, right? Maybe 1. Now, when you pick a number, you either can plug in into the original one, or you can plug in this one. I will plug it into the second inequality. So if I have x for 1, 2 times 1 is 2, minus 1 is 1. So I know that's 1, but all I care is the signs, right? I don't care about the value. All I care is sign. So I know that's positive. Here, x equal 1, 1 minus 2 is negative 1. Again, all I care is about the signs. I don't care about the value. A product of positive size and negative size give me a negative. So this region right here, it is a negative region. Last, we're going to pick a point in the region between 2 and infinity. So let's pick, I'll pick 100 just to be dramatic and just to show that it doesn't matter which point you pick. You can pick 3 if you want, or 4, but I'll pick 100 just to see. So when I plug 100 here, 2 times 100 is 200, minus 1, that's 99. So again, it gives me a plus size, right? And 100 minus 2, that's also positive. Okay? So positive times positive is positive. So this region is a positive region. Okay. Now remember, we want to find all the solution where the quadratic is bigger or equal to 0, right? So when look at the side chart, we want to pick the region where is it positive. Right? So from the side charts, I can see that at the 2 wings here, oops, at these 2 wings here, I have all the values that are positive, right? Am I allowed to include the 2 endpoints, 1/2 and 2? Yes, I do, because of this, right? Because of this. It's say greater or equal to 0. So I'm allowed to include 1/2 and the 2. So that means I'm going to have a bracket here and a bracket here. Okay. So if you want to write this into integral notation, that will be from negative infinity to 1/2. And I'm going to have a bracket in 1/2 because I'm allowed to include in it. Of course, we never have brackets in infinity. And then another region will be from 2 to infinity. The 2 included, therefore I get the bracket and the parenthesis on the infinity side. And because I'm picking one or the other, I'm going to have a union in between. Okay. So that's how we solve a quadratic inequality. Let's see another example. Let's see another example. This one a little bit more challenge because it's a rational inequality. So let me write down here. Rational inequality. All right. So I want to find all the solution of x squared plus x minus 20 divided by x plus 2 is less than or equal to 0. Okay, so similar process. First, we're going to factor these, right? So I'm going to factor the top. Well, the bottom is just x plus 2, so nothing there to factor. The top, I have x, and I need two number multiply, get me negative 20, and add up, get me x, right, or 1. So I see 4 and 5, and I need positive 5 and negative 4. Again, next step is the critical number. Remember, critical number means you're gonna find a root where these things are 0 or undefined, right? So for this rational inequality to be 0, the top has to be 0, right? So I need x plus 5 equal to 0, or x minus 4 equals to 0. And it's undefined where x plus 2 equal to 0, right? It's undefined where the bottom equals 0, right? So here I have x equal negative 5. Here I have x equal 4. And I have x equal negative 2. Give me undefined. Undefined. So I put it like that, so I remind myself that I never touch the negative 2. We never include negative 2 in all solution, because that will make the expression undefined. Again, side charge. Okay, and then I plug in these critical number here on side chart from smallest to the biggest. So first one will be negative 5, and then negative 2, and then 4. At x equal negative 5, we have this thing equals 0, right? At x equal negative 2, we have this thing is undefined, right? So I put a u there just to remind myself not to touch the negative 2. At x equal 4, we have the things also equal to 0, right? So again, I divide my number line into 1, 2, 3, 4 regions, right? And then next step, we're gonna pick a random number between the region to see where is this rational inequality is positive or negative, right? So between negative infinity to negative 5, so let me put negative infinity here. Between negative infinity to negative 5, I'll pick negative 6. Negative 6. Okay. You can pick any number as long as it's between negative infinity and negative 5, right? When I have negative 6 here, let's see, I'm going to plug it in here. I'm going to plug x equal negative 6 into this one. You can plug into this one, but I think it's easier to plug into the second inequality. So when x equal negative 6, I have negative 6 plus 5, that's negative 1. So again, give me a negative side. Negative 6 minus 4, that's negative 10, another negative. And then the bottom, I have negative 6 plus 2, that's a negative, right? So I have a negative on the top, that's positive. And then a negative in the bottom, give me the net of a negative. Right? So everywhere in this region here is negative. Next, I'm going to pick a number between negative 5 and negative 2. Let's see, negative 3 maybe? Negative 3. Again, let's see. When I have negative 3 for x. Put -3 here. -3 plus 5 is positive 2, so that's positive. -3 minus 4, that's negative. And the bottom, -3 plus 2, that's -1. So the top is negative and the bottom is negative. Give me the net of positive. So everywhere here in this region is a positive. And you may tell yourself like, hey, it looks like it's alternating. It's gonna be a minus and then the plus. It's a good guess. Most of the time it will be true, but sometimes it's not. So you gotta check all the way through. Right. So let's continue and check in. From -2 and 4, I'm going to pick 0, right? 0. So when x equals to 0, oops, 0 plus 5 is positive, 0 minus 4 is negative, and then 0 plus 2 is positive 2. Right, so the top is negative and the bottom is positive, so the net is negative. So here's negative, negative, negative. And between 4 and infinity, we pick, I'll pick 100 again, just to show you it doesn't matter. Any number you pick between 4 and infinity. If I have 100 here, +5, 105, so that's positive. 100 minus 4, that's 96, also positive. And the bottom 100 plus 2 is 102, that's also positive. So the top gives me a positive, the bottom also gives me positive, the net is positive. Okay. And again, we're looking for the region where this thing is what? Less than or equal to 0, right? Less than or equal to 0. So it is less than or equal to 0 at these region right here, this one and this one, right? Am I allowed to include -5? Yes, because it's less than or equal to, right? So I'm allowed to include -5. I'm allowed to include -5, right? How about -2? Am I allowed to include -2 because of the equal sign? No, remember, we never ever touch -2 because that's where the expression is undefined, right? So we don't ever touch -2. So I'm going to have a parenthesis there just to say that is we don't include, we get closer and closer to -2, but we never touch it. How about 4? Yes, we allow to include -4 of +4 because that's where the inequality is equal to 0. Okay, like that. Right. So our solution is from -infinity to -5. -5 include, there's fourth bracket. Union -2 to 4. Okay. Right. So that's how we solve a quadratic inequality.